we discussed 4 cases. The first case is displacement in the direction of the force. We can understand in better way. Displacement along a force. Displacement along force. The work done is equal to force into displacement. So work done is denoted by capital W, force is denoted by capital F, displacement denoted by small d. So therefore work done equal to force into displacement. So W equal to force into F into small d. F into small d. We take a simple example to understand. A boy pushes a book by applying a force of 5 newtons. Find the work done by the force in displacing the book through 20 centimeters along the direction of the force. Along the direction of the force. So we know that work done equal to displacement in the direction of the force. This is the example for this case. So work done equal to work done W equal to force FO into displacement small d. So therefore W equal to F into d. This is equal to force is given 5 newtons. So force is given 5 newtons. 5 newtons. Displacement is given 20 centimeters. So the centimeters is converted into the meters. So that this is a 0.2 meters. 0.2 meters. So therefore here you can substitute here 5 newtons into 0.2 meters. This is equal to 0.1 10 so 0.11 meter. So this is a Newton meter. This is equal to joule. Equal to joule. 1 joule. The simple example. Second case in work, displacement in the direction opposite to the force. Displacement in the direction opposite to the force. So the force is acting in this direction, one direction. The displacement is taking place opposite to that direction. So you see here, the force acting on an object and its displacement are in opposite direction. This work done by the force on the object is, you know that work done equal to force into displacement opposite to. So suppose let us assume this is the force is acting in this direction, displacement is in this direction. Displacement is in this direction. Then if this is the case, force and displacement, the angle is 180 degrees. 180 degrees. The example is you can take a ball is thrown upward direction. The ball is going up maximum height, while yet gravitational force is pulling that ball. So therefore the ball is throwing upward direction. So this is displacement is d. Let us say the gravitational force is pulling in this direction. The gravitational force is pulling in this direction. So force is in this direction, displacement is in this direction. So that's why they are opposite. Force is acting one direction, displacement is opposite direction. So this is the formula. So therefore here 180 degrees, we write the general equation is work done equal to force into displacement into cos theta. So therefore force into d cos theta, this is equal to cos 180 degrees. This is equal to 180 degrees equal to f into d into minus 1. cos 180 equal to 1 minus 1. So therefore minus f into d, f into d. Or otherwise you can follow another sign convention. Other sign convention, if it is moving from left to right plus, right to left minus. We can take this sign convention also, I think. Going up, this is minus, this is the plus, this is the plus. Like this also you can follow, but anyhow this is the best thing. Cos 180 degrees is equal to minus 1, so therefore minus f into d. So in this case, if you take one example, a ball of mass 1 kg thrown upwards reach a maximum height 5 meters. Calculate the work done by the force of gravity during this vertical displacement. So here the ball, the mass 1 kg is throwing up by, throwing up by hand. We have to apply some force so that we can throwing up that ball, but that throwing force by hand, that is not taken into the consideration. We are calculating displacement only in this problem, work done only in this problem by the gravitational force of earth. That's all. Gravitational force of earth. That means, so this is the upward direction of ball is displaced from here. Let us assume this is the 5 meters. The gravitational force is pulling in this direction, gravitational force. So obviously to push this ball upward direction, we take some force by hand. Obviously we can apply, but the hand applied force not taken into the consideration. Only we are calculating this displacement because of the acceleration due to gravitational force due to earth. Now we can solve this problem. Okay, ball mass equal to 1 kg. So acceleration due to gravity equal to G equal to 9.8 meter per second square. So this value we know that acceleration due to gravity. And what is the distance? Displacement equal to 5 meters. So simple. So this is the 5 meters displacement, d equal to 5 meters displacement. The gravitational force is that object is a gravitational force that we have to calculate, that is acting in downward direction. So the gravitational force of the earth is pulling downward direction. So mass of the ball, we know that, so that the force equal to mass into acceleration due to gravity. Mass equal to 1 kg, 1 kg, acceleration due to gravity equal to 9.8 kg per, acceleration due to gravity equal to meter per second square. So therefore this is the 9.8 kg meter per second square. This is nothing but 9.8 newtons. 1 kg meter per second square equal to 1 newton. So that 9.8 kg meter per second square equal to 9.8 newtons. Okay. Now we find out force. So therefore work done equal to height is there, displacement is there, force is there. So therefore displacement is in this direction. Let us say that I told you 180 degrees. We take like this. This is the 180 degrees. This is the 180 degrees. So therefore work done equal to force into displacement into cos 180 degrees. So this is equal to Fd into d into minus 1. No? This is equal to minus F into d. F into d. This is equal to minus into force equal to 9.8 newtons into displacement equal to 5 meters. 5 meters. So this is equal to minus 49 Newton meter or equal to minus 49 joules. This is the answer. Like this, we can understand the second case, displacement in the direction opposite to the force. Coming to next case, displacement in the direction perpendicular to the force. So displacement force displacement in the one direction, the force is acting perpendicular to that displacement. Obviously, in that case, the work done by that force on the object is 0. That means, so let us take aeroplane. You take aeroplane, so let us assume the aeroplane is moving this direction. In this direction, obviously gravitational force is acting in the downward direction. Aeroplane is moving in this direction. Displacement is the force is acting in this direction. Force is acting in this direction. So therefore, what is happening here? Of course, the aeroplane is moving in this direction because of the internal mechanism of that aeroplane. So that concept is, I think, depending on the action equal to reaction and Newton's third law. But we are talking about only the gravitational force influence. The gravitational force, because of that force, what is the displacement? What is the displacement and what is the displacement? That we are focusing. So therefore, this the gravitational force is obviously acting in this direction. In this direction, no displacement. Airplane, the displacement is in this direction. In this direction, therefore, this angle is 90 degrees. This angle is 90 degrees. Another way, F into d into cos 90. Cos 90 equal to 0. We know that F into d into cos 90 0. So therefore, this is also 0. Like this also we can take 0. Okay, this is the one thing. Another example, you can take porter in the railway station. Suppose the person is here, is the head. Over that he put it luggage. This luggage, the head is exerting force in this direction. In this direction. So therefore, suppose this is the platform. He is walking along this platform, so that the displacement is in this direction. The displacement is in this direction. Displacement d and force is acting in this direction. We are not talking about the gravitational force. Force exerted by the head. So displacement is in this direction. The force is in this direction. Displacement is in this direction. Again, the relation is perpendicular. So here also, in this case also, the same case. Work done equal to F into d into cos 90 is equal to same thing. F into d into 0, this is equal to 0. Another case, you can take another case. Porter, suppose there are steps like this. So the porter is here. Here luggage is here. This is the force is exerting by the head in this direction. Suppose this person is climbing these steps, climbing these steps. Here in this case, the force is acting in this direction. The force is acting in this direction. Displacement from here to here, he reached this point. He reached this of course, suppose he reached this point, let us say that he reached this point. This is the head, this is the luggage. So therefore, the displacement is up to this. This is the displacement. This is the displacement. This is the displacement. So therefore, displacement is also in the upward direction. So therefore, work done equal to force into displacement. Here cos theta 0, both are in the same direction. So therefore, or other same direction, or otherwise you can write it here also, displacement here also. So therefore, cos theta, this is equal to cos theta is equal to 0 degrees. So f into d into cos 0 equal to 1. So therefore, f into d, positive value. Okay, you can take another example. This person is coming down from the steps. First person is here. This is the luggage. The force is acting in this direction. You know that. So he is coming down. So therefore, at let us say up to this. So therefore, the displacement is displacement from here to here. This is the displacement. Thing is that we have to understand here, the force is acting in the upward direction, displacement is a downward direction, coming down. So therefore, in this case, work done equal to force into in this case also d into this is the angle 180 cos 180 degrees. So therefore, f into d into minus 1, this is equal to minus fd. Of course, in the horizontal direction, displacement, to be honest, this object is not displaced. The person is displacing. But here, acceleration due to gravity, while he is climbing up, the acceleration due to gravity is acting on this object. That's why we have to take this displacement is positive. While he is coming down also, acceleration due to gravity is working on the mass of the object. So therefore, the displacement is in the downward direction, negative. This is the case. This is the thing. So you have to understand in this quarter.